The general theory of evolution says that all living things came from a single cell, and that cell came from something like a primordial soup. And for me as a chemist, the hardest problem for evolution is the origin of first life from non-living chemicals, and this is commonly called chemical evolution.
Most people have heard of the Miller-Urey experiment, and it's in most textbooks still today. They wanted to see if organic molecules could come from inorganic precursors. So they took some simple chemicals and they ran them through a spark chamber. And most of the products they got really amounted to nothing more than a brown tar, because random chemical reactions produced random molecules. And yeah, they found a few amino acids, but in a mixture of left and right-handed forms. But what they didn't find are certain specific amino acids that are critical for life. They didn't find nucleotides. They didn't find any large biomolecules.
To get living things, we need lots of huge molecules, and that means we have to get little molecules to combine into big molecules. Now, the problem is that chemicals don't react in that way. Everything I've learned in real chemistry shows that the reactions go in the opposite way from what's required for life to come from non-living chemicals. Any chemist trying to do that would not have water in the reaction, because water tends to drive the reaction in the opposite direction towards the little molecules, and yet the primordial soup would inevitably have loads of water in it. So it's the last place any real chemist would try to make proteins or DNA. Another problem with chemical evolution is called the chirality problem. Now, amino acids in proteins and sugars in DNA come in two mirror image forms, like your left hand and right hand. But all the amino acids in our body are left-handed, and all the sugars in DNA are right-handed. But a primordial soup would have an equal number of both, and it's quite complicated to get a single-handed mixture. And a primordial soup does not have that know-how, and therefore it's totally unsuitable for the origin of life.
The most common scenario for the evolutionary origin of life is called the RNA world. Here they imagine an ocean or a lake full of RNA molecules that are able to reproduce themselves and that slowly evolve into the first reproducing organism. The RNA world is a desperate attempt, a last straw, a grasping at nothing, and it is completely unscientific.
When you see design, what about the design of the two big lights we've got close to us, the sun and the moon?
Well, there are a couple of things I can talk about. First of all, the sun is 400 times larger than the moon. So when we make a model of the two, if you had a ball the size of an inch across, that would be the moon, and the sun would be 400 inches across. Gives you a bit of scale.
That's not what we see, though.
No, because you see the sun is not only 400 times larger than the moon, but it's also 400 times farther away. So if you take something and move it as far away as it is larger than the other, they have the same size to us. Both the sun and the moon appear to be about a ½ degree across in our sky. Now, on rare occasions, the moon passes between us and the sun. Doesn't happen very often, about every year and a half somewhere in the world, usually in Timbuktu or Siberia or Antarctica or something. We get a total solar eclipse. And when that happens, the moon just barely covers the sun up. If the moon were a little smaller or a little farther away, it wouldn't do it at all. If it were larger or closer to us, it would be grossly over total, and wouldn't be nearly as spectacular. We get these rare and very spectacular eclipses. Well, I've been to one total solar eclipse back in 1979. My wife and I drove 3,500 miles round trip in 5 days from South Carolina to up 100 miles north of Winnipeg, Manitoba. That was in February. The snow was this deep up there. They have 4 seasons: early winter, midwinter, late winter, and next winter. And it was cold. Yeah. And we did it in 5 days. Didn't have a whole lot of time. An old car, by the way. We drove a 22-year-old car when we drove up there, and we were there for 2 minutes and 46 seconds of totality. And it's truly remarkable. People that know me know that I talk a lot more than my wife does. And so during the eclipse, we ran this tape recorder, ran it for about 20 minutes before, during, and after. We played it back later, and it's the strangest thing. During totality, my wife is just chattering away, And I hardly said,
your sight.
I didn't say 2 words. I was dumbstruck
From what you were seeing.
Yeah, it was amazing. Most
Yeah.
spectacular thing I'd ever seen. If I made a top 10 list of things I've experienced in my life, it would be the top 4 probably. There's another one coming in 2017. I hope to see that one. It's first one since then coming across the continental U.S. It tells you how rare that they are.
Do you think that's a design that
Well,
God gave to us?
It's the if you look at the other satellites, 170 or so in the solar system, none of them have those kind of requirements. Either they don't happen at all, or they're grossly over total, so they're not very rare and they're not very spectacular. You know, it takes. I read once that on a given place on the Earth, we get a total solar eclipse about once every 400 years. So either if you see one, you're either very lucky or you plan to be there to see the thing. I've only seen one so far, and I'm past 60 already. And so these eclipses are spectacular and rare, and this is the only planet on which it matters, and it's the only planet on which it happens. I don't find that to be just a coincidence. I think there's more to it than that. But there's another more important thing about it. The moon's orbit is different. We have the plane of the Earth's orbit around the sun. We call this the ecliptic. Imagine a flat plane here. The sun's here, and every year the Earth goes around like this, and it causes the sun to seem to move through the stars. That defines this ecliptic across the sky, this big line across the sky, the plane of our orbit. Now, the moon's orbit is very close to that plane. It's tilted a few degrees, but basically the moon orbits around the Earth in the same plane that the Earth orbits around the sun. Of the 170 or so satellites in the solar system, it's the only one that does that.
Is that right?
All the others have different orbits. The most common type of orbit is above the equator of what we call the equatorial plane of the planet. And each of the planets have different tilts. Our own tilt, our own Earth's tilt's about 23.5 degrees. So if this is a plane of the Earth's orbit, there's another plane, the equatorial plane, that's tilted 23.5 degrees to that. And if the moon were like other satellites in the solar system, it would be orbiting in this plane, not in that plane. But the interesting thing is, that tells me something right away, that the origin of the moon must be different from other satellites. It must be unique, which we kind of know that from Genesis because of the purposes involved. I believe the moon is unique, and the origin scenario perhaps would be unique as well. And you know, astronomers have tried to claim, well, we need to study the satellites of the other planets, hopefully to learn more where the moon came from. Well, I say nonsense, because the moon's orbit is unique in the solar system. Now, again, you could argue that's a coincidence, you know, but how many coincidences are you allowed before you begin to realize, well, maybe these coincidences aren't coincidences at all?